Being recorded.
I don't know why, thanks.
I mean, I thought, oh my God. Did you really watch the video?
Oh, no, okay.
Yeah, everything.
Why is it my head? I did look at the video.
Would I can find it? I can find it. I'm pretty fine.
You shouted vagina.
Well, why? Well, we're being recorded again, by the way. What's wrong with you people? Okay.
No.
Yes. Hey, Nate, give me a second. Wait. You guys also communicating with your parents about IT.
What did you guys get for baby? Yes, something that's like meat to something like. No, they said that.
Ah, shit.
Okay, we all do so.
No, no, with the document there, import.
I don't know. They want me to do this. I'm not. I love it. It's going through us. What you lose the shifts?
Okay, let's have a look, guys. Okay. Right, so we've got a function here, and they tell you it's a cos graph, right? Okay, so we've got a function, and they tell us that this function is of the form a cos x minus b, which means it's been shifted by b across. You with me? What is that? What effect does this b have on the graph? It's shifted across by b units. You with me? In the opposite direction. Okay. So, and it's between 0 and 360. So the first question, so a normal cos graph, guys, does what? It starts at 0, it has its maximum value, right? A normal cos graph that hasn't been horizontally shifted. It will always be 0 degrees and a maximum value with a cos graph. With sine, it will always be what? 0 degrees and 0. Sine graphs have that shape, right? They start at 0. 0 degrees is your 0 line. You with me? Or the middle line if it's been a vertical shift. Okay. So here they've told us there might have been a change in the amplitude. A's got to do with the amplitude, right? And B's got to do with the horizontal shift. Normally the maximum of a cos graph is what? It's 1, right? Now your maximum has a y value of what? 2, right? What's your displacement from your 0 line? There hasn't been a vertical shift. This is still your 0 line. So that displacement is 2, right? What does that give us? A or B? Okay, so A must be equal to 2, right? Are we all good with that?
Yes.
Okay. If that was 20 degrees negative 2, A would be negative 2. So far, so good? Right. If this point over here, the graph did this and went from here to negative 2, then A, if that's a 20 degrees negative 2 and then had that shape, means it's been reflected, so A would be negative 2. Okay, right. So are we happy that A is 2?
Yes.
Normally the maximum is where for cos graph? You have to know this. At 0 degrees, you have your maximum value. Now, for how many degrees is your maximum value? No, your degrees.
20.
So you'll be shifted how much? 20 degrees to the right compared to normal, right? Normally it should be here. Now it's gone 20 degrees to the right. So in the equation, okay, you should end up with the equation f of x is equal to 2 cos x. Now with horizontal shifts in the opposite direction, right? So you should get 2 cos x minus 20. So what is b? Is b minus 20 or is b 20? B is 20. Because in the formula you had minus B, you with me? So just check when you put B back in, does it give us the right answer? It gives us X minus 20. If this had been cos, if they said that the formula was cos X plus B, then what would we write B as being? B would be negative 20. You with me? So if they said to you it's cos X minus B, then B is 20, because you've got to end up with what? Cos X minus 20, because it's gone 20 to the right. But if they said the formula was cos X plus B, then B would be minus 20. Does that make sense, guys? Okay. Right. Then they said, go find, everyone okay up to here? Sure? Okay. Then they said, okay, write down the coordinates of points A and points B. Okay. So points A and point B. Okay. So normally a cos graph does what? A normal cos graph goes to the 0. Then what happens? An important step happens every what? 90 degrees. You with me? Has there been a period change of this graph? No, the period of this graph is still going to be 360. You with me? Takes 360 to complete a full wavelength. Okay. So normally a cos graph goes as a 0 at 90 and then has a minimum where? Something important happens every 90 degrees. You with me? So then you have a minimum at 180, right? But we know this graph has shifted 20 to the right. So instead of being at 180, it's going to be at, what's 180 plus 20? 200, right? So A is going to have an X coordinate of 200, but your minimum is what? Negative 2. Your maximum is at 2, your minimum will be at negative 2 because of that symmetry. Capish? Okay. So A, coordinate of A is going to be what? 200 degrees and negative 2. Now, then what does a cos graph do? So normal cos graph goes to 180 minimum, right? Okay. Then it has what? Your next important point will be 90 degrees afterwards, which will be at 270, right? Okay. You'll have your x-intercept at 270, and you'll have your maximum at 360. So I'm afraid you've got to have that picture of a standard cos graph and a standard sine graph. You kind of got to know that in your head. Okay. So now, at B, it's an x-intercept, right? Normally, where's the x-intercept? How's this graph moved horizontally? 20 to the right. So instead of being at 270, it's going to be 270 plus 20, which is 290. What's the y coordinate going to be? 0. Yeah, agree, Kuching? Let me do the correct first. Okay, right. So now it's going to be what? B is going to be 290 degrees and we're good, guys. Half time. I need to quickly speak to you. No trouble. Don't worry. Okay. All right. Right. Next question. Okay. No, because we only just started working. Okay. Right. Make it set 15 minutes from now. Go. And then at half time,
Seriously,
I have to murder him all. And then I have to do register as well. Okay. And to do first day. Oh, it's a busy break. Okay. Right. Next one. Calculate the y coordinates of point C. Okay. Right. Where is point C? Suggestions. If you've got a graph, and you know any graph in the world, whether it's a trig graph, parabola, hyperbola, if you know an x coordinate, how do you find the y coordinate that goes with it? Sub it into the equation. Do you know the equation of this graph now? Yes. What's the equation of this graph? 2 cos x minus 20. So what are you going to do? Sub in x is equal to? Right, off you go. Right. Everybody's still warming up? Then you're going to need calculators. You do, yes.
Just tokens. That makes sense.
That's my first start today.
Exactly.
Haven't told me I'm very fat. All right.
Enemies. So it's because you're busy babies. You're dieting babies.
Yeah. I don't think I'm fat. Not at all. And then something.
I did. It's like
And then something. stretch.
Yeah, welcome.
Okay. Tell him we some in crochet costumes. Okay. All right. So, Nabia, we put in x is equal to 360 and I get f of x is equal to 2 cos 360 minus 20. In other words, 2 cos 340. Sorry, my boss. Okay, work it out. I want to. Keep going with the next question. Go. It is the answer. Like interested to plus one comma. Okay. So if you look at it's one okay. That's why I find once you say so that it was used why not they really like found the problem with it's a copy Okay. So next one, what do you do this one? Oh, 10 times cos 340. 1 point? 1.9. 1.9. Okay, fine. Still one decimal digit. Okay, right. Then it says if the y, okay, this is a bit confusing. If the y-axis is translated, that just means moved to position y1. Okay, and the x-axis to position x1. Okay, so what the hell are they saying? They're saying my new axes are going to be here. Okay, so this is my new y-axis. Okay, and my new x-axis is over there. So they haven't moved the graph. So they think it's to kind of move the graph, right? Okay, so if I do that, I don't like this question personally. If f in relation to the new set of axes defines a sine graph, cheapest, creepest, write down the possible equations of this graph. Okay, so
it's also been translated to the x1 position.
yeah, to position x1, which so it's going to x1. So those are my new axes, and this is a sine graph, right? Okay, so what have we really got here? We've got a sine graph. They're my axes. Okay. This point, this new minimum, okay, will be, what will this be on the new axis? Well, it was, okay, what is this value here? 110?
Yes.
Okay, and this, okay, so this is 110 degrees, and that's -1, right? You with me? So this new axis from here, from this point over here. So I've got a graph now that does this. Okay, it goes through something over there. This is 110. 110 to get from 110 to 200. What have you moved through? 90, right? Okay. Because this is 110, that's 200. So to get to the minimum from 110 to 200, you've gone 90 across, right? Okay. What's the y value going to be? If this is the new axis at -1? No? Negative? Negative 1, right. So it's going to be a sine graph that goes through 90, -1. Okay? Right? Okay. Then, are we right about that? 110 to 200 is 90, right? Then it will repeat. Then it's going to go, we don't know what that is. 90, -1. Okay. Normally a sine graph does what? So I don't like this question very much, I'm not going to lie. 90, -1. If it went through 0, 0, it would be easy. Okay. What's another point we had? What was the coordinates of B when we worked out B? 290, 0. So now it'll be 2. Hey guys, come on. Sorry, you're talking about maths. 290 minus 110 is 180. You with me? Look here. B we said was 290, 0, right? But now it starts at 110, right? Vish? Okay. From 110 to 290 is how many degrees? 180 degrees, right? So it's going to be 180, 0, right? Okay. What I don't like about this diagram is this should actually be going 181. Good. Okay, because this is my new 0 line. Good. So then it'll be 181. So 90 minus 1, 181. And this will be that's not a maximum, right? Okay, what was C? What's the coordinates of C? We worked it out. A hard question. 90 minus 1, negative 1. 181. But 181 is not the maximum, right? The maximum, okay, would be at this point over here. What is this point? Okay, 122, right? Okay, on this graph, what will that be? Okay, we're getting there. Okay, if this is 120. Okay, and this, sorry, this is 20.
Yes.
And this is 110. In terms of this axis, what's that value going to be?
Which axis?
If that's 110 over here,
Yes.
and that's 20, how much have I moved to the left? 90, right? So it's going to be negative 90. Okay, so you're going to have, okay, negative 90, okay, and what's this going to be now? Negative 90, and if this is my new x-axis, how much have you gone up to get from there to 2? Okay, it'll be negative 93. Okay, so we've got a picture of what's going on here. Have you got that point? This point went with this point over here. You had 22, right? This y-axis is now 110, right? Okay, so I've got 90 to the, okay, so this is now the new naught. Okay, so if that's the new naught, to get from 110 to 20, you've got negative 90 to the left. So this is my maximum value. Okay, and this over here is my minimum value. Are you with me? I would be reluctant to let this question in the exam, quite frankly. Okay, so I think they have to at least tell you if it's a vertical shift or horizontal or what it is. So if they wrote it as a sine x plus 2 or a sine x minus b, that would be acceptable. Okay, but like this, it's a bit tricky because, anyway, don't worry why it's tricky. Okay, so now you've got this sine graph over here. Okay, that goes through 93, 90 minus 1. So if there's, I would have told you that there's a vertical shift here. What's the middle line of this graph? Picture map. What's the middle line? Because whatever your middle line, what's your middle horizontal line? What's halfway between 3 and -1? Why am I doing this? Okay, if you don't get this question, don't panic, but it's okay. Between 3 and -1, what's the distance? 4. Halfway is 2, right? What's 3 minus 2? 1. So your middle line is y is equal to 1. Why do I know that? Because this is a maximum and this must be the minimum. And halfway is your middle line. Okay. So if this is my middle line, right? Okay. And it's going through, okay, this, and it goes through 90 minus 1. Okay. Are you with me? Okay. Right. Now, so I know it's going to be, it's a sine graph, it's going to be something plus 2. Plus, what did I say? Plus 1, sorry. So it's going to be something plus 1. Okay. Then, what about the number? What's the amplitude of this graph? What's the amplitude? What's the distance from 1 to 3 and from 1 to minus 1? Come stay with me for a little bit. What's the amplitude? No, let's think about it. From 1 to 3 and from 1, okay, to minus 1. How much have you moved? 2, right? Okay. And it's the right, so this is going to be 2. Sorry? Sine graph starts at 0 and goes to A. So it's going to start, yes, it's going to be negative 2. Just as a tough question. Okay, so y is equal to negative 2. Okay, because it starts at 0 and goes down. Yeah, okay. And then normally a sine graph would go through 90 degrees minimum. Is this going to be 90 degrees minimum? Yes, it is. So there hasn't been a horizontal shift. So it's going to be negative 2 sine x plus 1. Tough question. Okay, at this point, it should be a bit clearer here. Okay, that is 1. That would make your life a bit easier as well. If I recognized here, didn't quite see that value is 1. Okay, so normally a sine graph is at 0, 0. Now it's at 0, 1. You with me? Did anyone vaguely get that? Okay, so go through it again quickly. Okay, axes moved. Okay, the axes move. I usually just kind of redraw my graph. The minimum now is at 90 minus 1. This, I made my life confusing by not recognizing that this is 0, 1 over here. You with me? At that 110, it's 0, 1, right? Okay. So normally a sine graph starts at 0, 0. This one starts at 0, 1. Just give me a second. 3 more minutes because I ran out the class for a while. This starts at 0, 1, right? Which tells me it shifted up 1. That's the one way I could see it shifted up 1. The other way I could see it shifted up 1 is because the gap between the maximum and minimum. I think I would insist, if this was a question in the exam, I would say to you, the form of this graph after that, if the axes are moved, is y is equal to a sine x plus b. Okay, I would not let that question go for moderation like that. Okay, I'd write it as a sine x plus b. So you've got to identify what's the vertical shift, okay, and what's a got to do with the amplitude. So once you've got the vertical shift, then you can look at the amplitude and say, what's the distance from there to there? It's 2. I don't want you to panic if you don't get this question. Okay. Here. Two ways to get the vertical shift. You could recognize that normally a sine graph does this. It starts at 0, 0. Now, because this was 110, this is a new y axis, right? So now it's going to be at 0, 0. It's at 0, 1. It tells us it's gone 1 up. Are you with me? Okay, but probably even the better way is to recognize that this is negative 93. And whenever I look for vertical shifts, I do this. I say, okay, what's the maximum? Maximum has a y equal to 3. What's the minimum? Minus 1. What's the distance between 3 and minus 1? Between the maximum y value and the minimum y value. The rabbit has to hop 3 plus 1, which is 4, right? So halfway will be 2 and 2.
Oh.
Do you agree with me? Okay. So then I know, okay, my middle line is 2 down from here. 3 minus 2 is 1. Okay, 1 minus 2 takes me to minus 1. So I always find the middle line, the new middle line between the maximum and the minimum is going to be what your vertical shift is. Makes sense, sort of. Okay. And then I have to look at the amplitude, but I would insist actually that they do that in the question. Okay, right. Tough question. 806. 807. 4-minute break, 8:11. Okay, go.
Oh, I'm so sorry. That's not.
What that? Oh, yeah, sorry. Give me 1 second. How do you spell the name of my family? Kiara. Kiara. CYARA. You're gonna take your S?
And bears who segregated.
I don't know. I'll find out. What time do you have to be here at 6, eh? We leave at 6:30. You're not here, I'm telling you this now. You're not here. I'm that bus at the very latest, I'll give you 10 minutes leeway. Not here at 20 to 7. Tell your parents they're going to be chasing after the bus. Because otherwise, what happens is this, guys, we hit traffic, you leave at 7 or 7:15, we hit traffic on that highway going out. And a journey that should take us an hour and a half will take us 3 hours. Okay, so you're running late, say, Mama, okay, Gitsela I petrol, because we need a lot of petrol to get to Michalisburg. Okay, right. Okay. It's a nice place, guys. It's a nice place. There's access. Okay.
Oh, no, that's I always. It might just be your friends where, but yeah, it's not like there's two buses. Oh, it's going to. No, yes, but say that they just enough of it's for, yeah.
Indy is the person, my administrative contact. Let's see who Indy is. Oh, Indy looks quite a whack job.
I joined it.
There it is. She's the administrator, you're not going to beat her.
So what is the administrator?
But that looks a little bit cooked, right?
The guy who owns the whole company has these shoes on. Separate as like easier.
I love him. Nick's a fascinating. He is a really interesting guy. Okay. All right. Let's do register. Yeah. And then Remu. What am I doing? Register.
Oh no. Yeah.
Right, let's have a look. Sophie, it's Monday. Hey, yeah, Monday. Sophie is here. Ella is here. Ankita is here. Am is here. Zara's here. Karina is here. Picanto is here. Camo is here. Remo's here. Renee is here. Circle's here. D is here. Nabi is here. Malika and the lady. And Tweet is here. And Zumi is here. Okay. All right. I know. Okay. Go to the next page, please. Okay.
So what happened to your oh, okay.
Yeah, you changed my life. Thank you. Right, I want you to try and do this question. Okay. You told me the magic dots. Right. Magic dots. Right. Okay. Right. I'm trying to find out is it access to the Wi-Fi card. India's going to check me. Yeah. Pass on next question. Series of change. Okay, so let's. Right, so normally the period is 180, right? What we say, so we say that if you got y is equal to tan dx. Okay, normally, the b over here, what did they say?
Yeah.
Tan dx. So guys, let's think about this. The first question we've got to do with this tan graph. First of all, as soon as you get something like this, this is indicating a period change in the graph, right? Okay, that number is not 1, might be 1. Okay, so in order to figure out, normally what do we say? If we're given the equation, for a tan graph, we say the period is equal to what? 180 divided by b, right? For sine and cos, what did we say? Yeah, yes. If we had sine cos x and b cos x, normally we say the period is equal to 360 divided by b. Wer mehr Bella versuchen wir. Das sind wir big wellness. Okay, right. She saw. Right, 360 divided by b, right? Okay, that's for a sine and cos graph. So if I have this, if period is 180 divided by b, and I manipulate that equation, I get b is equal to 180 divided by the period of the graph. And here you get b is equal to figure out b, you'd say b is equal to 360 divided by the period of the graph, right? So the first thing you have to do is speak to your neighbor and say, what is the period of this sine graph over here? Okay. What is the period of this tan graph, sorry, over here? How far does it take to complete a full wavelength? At 360y, how did you get that? What's the distance between the asymptotes? This was equal to negative 180. This is 180. What's that distance from negative 180 to 180? So the period is 360. So go tell me what b is. So in this case, what's b going to be? Remember, we'll chat after the lesson quickly. B is equal to 180 over 360, which is a half.
So what does the 180 stand for?
What does the 180 stand for? What 180? This. The one vertical asymptote is x is 180, the other is x is minus 180, right? So the distance between your two asymptotes, it's heading towards your asymptotes, right, is 360. That means the period of that graph is 360. And a tan graph, period is 180 divided by b. So b is 180 divided by the period, so b is equal to a half. You with us? Okay, right. Okay, so b is equal to a half. Right. The next one says go find the turning point of A. Well, it's okay. You started, I'm going to start it as well. Okay. So they tell us it's cos x minus 30. What shift has happened, guys? If it's cos x minus 30 compared to the normal cos graph, how's it shifted? 30 to the yes, you said the right words. Okay. Can I say it?
No.
Please, man. Horizontally. Horizontally. Bye-bye. Right, okay. Okay. G of x is equal to cos x minus 30, right? Nanette, help us that way, please. Right. I can see when there's the distance, the time between the blinks becomes long. Okay, all right. So, okay. So 180. So normally a cos graph does what, guys? What's a normal shape of a cos graph? There hasn't been any other shift, right? Okay. This was minus 180. So we look at naught, right? There's a y-axis. That's the y-axis. Fish? Okay. What's the normal shape of a cos graph? Wait, it has its, you need to get the, it starts at the maximum, right? Okay, so it starts at 0 degrees maximum. I know the maximum should be 1. Why? Because there's no a in front of that. Okay. Right. So the maximum must be at, have a maximum value of 1. You all understand that? Because it's 1 cos x minus 30. So for a, okay, you're going to have a maximum of 1. Are you happy with that? We all agree that that's a maximum. Okay, and that's a 1, so that must be 1. But then normally the maximum is where? Normally the maximum is at 0, right? Now where's the maximum? Well, it's shifted how much? 30 which way? To the right. Okay, so it's shifted 30 to the right. So this must be 30 degrees and 1. Does that make sense? Okay. So now the last question, we were given the graph, we had to find the equation of the horizontal shift. Now we're given the horizontal shift, we've got to go find the maximum. Is he with me? Okay. Minute? Yeah. Okay. So A, the answer is 30 degrees and what?
1.
Oh, write down the equation of the asymptotes of y is equal to, okay, try the next one. Ask all you're asking yourself here, okay, is you're saying to yourself, how much has the graph shifted horizontally? That's all you're asking. The B we've dealt with. Okay, so you're asking yourself, how has it shifted horizontally? Which direction? If it shifted that much horizontally, what will the equation of the new horizontal asymptotes be? Check with your math. And that next, start her efficiency. Those kids are on FB or something. It's a joke. That is all kind of lost. But am I right? Those kids can talk. Right. Okay. All right. So now, Taylor, what do you think? If it's everything, if everything's hard, everything moves on this graph. 20 to the left. So if this was at minus 180, what's it going to become now? What's minus 180 and another 20 to the left? Come on, come on.
Minus 1. It's too much.
20 minus 180. You move it 20 to the left. Where do you end up at? Yeah. Minus 180. This whole graph has moved 20 left. So I want minus 180. I walk 20 left. Okay. So the one asymptote will be minus 200. Gotta get the other one. So circle. If I'm 180, la.
Yeah.
Where do I end up at?
Yeah.
Where do I end up at? Yes, no, but I'm now asking for the positive 180. Yeah, 180 and I go 20 left.
Oh, but sir, look, sir, why wouldn't you stuff like it's oh, never mind.
Okay.
No, actually no, sir. No, never mind.
Okay. All this is saying to you is if you pick the graph up and move it 20 to the left, what are the new asymptotes going to be? Okay. Right, try the next page. Ah, this is still about this graph. Oh, yes. Okay, but try to think about it. What is this saying to me? Okay, what was the original equation of g of x?
G of x was cos x minus 30.
Okay. Right. So we had this cos x minus 30, right? And what did that cos x minus 30 look like? It was a cos graph, now it's gone. It was at 30, the maximum was at 30 and 1, eh? Okay. And the minimum would be at, well, normally it would be at 180. Now it's going to be at 210 minus 1, right? Okay. So now they're saying to me, so that was my, am I right about the shape of my graph? Okay. Yeah. Okay. So let's go back to this. Let's rather go back to the graph. Okay. So I've got this graph, right? This is my graph between minus 180 and 180 of what? Cos x minus 30. Okay. P of x is equal to cos x minus 30. Now, what did they say? Give me the question. Okay. If find h, determine the range of h if h of x is equal to 2 times g of x plus 1. Okay, so what are they saying you've done to that blue graph? At the moment, what's the amplitude of this blue graph? It's 1, right? If I times it by 2, so what's the equation going to become? It's going to become h of x is equal to 2 cos x minus 30 plus 1. Okay, so what have you done to the amplitude? At the moment, the amplitude is what? The amplitude is 1, right? Now the amplitude becomes 2. So the new amplitude is 2. And what else have you done? You've moved the graph up by 1. Okay, so let's look at the maximum value. So tell me the coordinates of the new maximum. You're not subbing in. You don't have to sub in. I mean, you could if you wanted to. Okay. Let's have a look. Try to get speak to your neighbor. Try to get the coordinates of A after you've done this. You can think or you can sub in. Okay. Has it shifted horizontally compared to the original graph? Has it shifted? No. Compared to the original one we drew? No. Okay. It was x minus 30. That hasn't changed. So it hasn't shifted across, right? Okay. So it hasn't shifted across, hasn't shifted horizontally. Okay. But the amplitude has become bigger. Okay. So if I made the amplitude 2, it would become 32, right? Okay. But then I'm going to do the whole thing and move it up by 1. You with me? So this point would become 33, right? The maximum will be 30 and 3. The other way you could do it is once you recognize it hasn't shifted horizontally, go sub 30 into there. Go do that. Go 2 cos 30 minus 30. In other words, 2 cos of 0 plus 1. Put that on your calculator. 2 cos 0 plus 1 will give you 3. You with me? So the new maximum is at, so your new maximum is at 33, right? What's the range? The range is from the maximum y value to the minimum y value. So now what do I have to find? The new minimum y value. Okay, so where does the minimum happen? Okay, the minimum happened over here. What is the coordinates of that point? Well, normally, these are tough questions. Normally, your minimum of a cos graph, it'll go, if you're going to the left, it'll go 0, negative 90, negative 180. But this graph has shifted how? This cos x minus 30. It's gone 30 to the right. So now it's going to, you didn't have to even really know this. Hey, it's going to be at negative 150. That actually is not important. Okay, what's important is that the minimum would be negative 1, right? 150 actually doesn't matter. Because if it, are you happy that the minimum y value, this doesn't matter. But the minimum y value is negative 1. Okay, because the maximum was 1 and there hadn't been a variables. Now what have you done? Well, the first thing you've done is increase the amplitude. So if you increase the amplitude to 2, what's this going to go down to? Negative 2, right? So now it goes to a y value of negative 2. But then what? Then you move it back up 1, right? So it goes back to negative 1. It was at -1. The minimum, if the maximum was at 1 on the original, the minimum would be at -1. You with me? Don't worry about the 150. Okay, it wasn't important. But the minimum's at -1, right? Okay. Then, but the question is really testing this. What does that do? Changes the amplitude to 2. If the amplitude of a graph, okay, becomes 2, the minimum will now be at, the maximum will be at 2, and the minimum will be at -2. You with me? So the minimum now is at -2 if I change the amplitude. So I've changed the amplitude, okay, by putting this number in front. But what else have you done? After you've changed the amplitude, you have to move it up, the whole graph up 1. So you're sitting now at -2, the y value, but now you move it back up. So what's the y coordinate going to be? -1. It's actually not going to move. Okay. So the minimum y value, this is becoming a mess. Okay. The minimum y value is going to be at, what was the minimum y value? Let's go back. Minimum y value is -1, and the maximum was? So what's the range? Range goes from the smallest y value, which was -1, up to the biggest y value, which is 3. So the key thing was recognizing changes the amplitude to 2. Okay, move up 1. Because you're working with range, you look at your minimum and maximum y value. Fish? Okay. All right, guys. Tough stuff there. Okay, but these are good questions, actually. Even though they're hard. Sorry?
Oh, no.
Okay. I don't want to pray. I'm going to save that. I'm going to save that on my desk. I know, but they're fixing all together. Remo.
Too much. So I was going to buy this. We would have gone on camp today and come back before Friday. Why we come back on Friday? Could have gone today. It would have made someone. It would have made before we go to every day. On Friday is a quick. The Bible is going to play to the outside. Bye guys, have a good day. Yeah, I got tired of listening. Thanks, sir.
Bye.
Thanks, sir.